Alright, good Sunday afternoon to everybody. I have got an interesting project here. I keep forgetting to shoot any video because it's not my, I'm a machinist and mechanic and whatever else you want to call me. I'm not a video expert and I forget all about it. But so this is part of a final drive off from a Caterpillar skid steer. And this was a bearing bore here that had spun out a bearing in it. This bearing was just rattling around in the hole. This is a brand new one, and it had, I didn't bother measuring it. I'm going to say from the way it felt, probably 20 thousandths of clearance on it. So what I've already done, as you can probably see, is I've gone in here and brazed that surface up. I did that because the options here were to basically bore this out and sleeve it or find a way to build the surface up. I didn't like the idea of boring it and sleeving it because it's not that thick of a casting, and if I'm going to do a good job of boring and sleeving, then I run into an issue where I really ought to have, I figure on stuff like this, I don't like to go less than 100 thousandths thick on the wall thickness of my sleeve. And there's two problems. First off, that would have thinned this out, and right now it's such a mess from the, this is all flux that's flowed over on the edge. But this is a tapered surface here that, I don't know exactly what they're called, but they've got those steel face-type seals in there. And the way those work is they have an O-ring behind them that's up against this tapered surface, and that's what provides the spring effect to keep these two steel faces against each other. I'll show them to you in a minute, just in case you're not familiar with what I'm talking about. Got them here in the office. Let's see here, we'll bust them out of this bag. I already had them out because I was trying to make sure everything else was okay. So you've got two of these. One that goes in the housing and one that goes in the axle tube. So you can see here, we've got this polished ground steel ring with an O-ring on the back of it, and the outside of this thing is tapered and the bore is tapered. And you got these two rings that face up against each other like this. And those O-rings are what provides the tension for that. And so the problem is that that tapered bore would have got machined right out of there, and I would have had to figure out how to recreate it as part of my sleeve. It was like, nope, we're not tampering that. So despite the fact that it looks like quite a mess, I haven't even touched that surface. I was very careful brazing this up. So I've got some flux that's flowed over onto it. That'll knock right out of there and it'll buff up. I didn't bother trying to clean it out of there because chances are, as soon as I start cutting the actual brazing, this flux that's up in the taper will blow right off there. So anyway, on Friday, I brazed this thing all up, and then it's been sitting just cooling back down since then. So now I'm in the shop with the idea of turning this. So what I'm up to right now is, I did initially, so this machine, this face is machined, but then otherwise, I've got another bearing bore here on the other side. So what I did is grab this from the inside with my 3-jaw chuck, and that's the part I forgot to document. I played around with it. The problem I've got is my 3-jaw chuck is not that accurate on ID grabbing. So I could get, and then I was on this face here, I'd polished this up, so I ran an indicator on it, played with it until it was running true in the, I guess that'd be the Z-axis, as far as I got it to 0 run out with the indicator on this face. But then when I came over here and checked this surface, I was running almost 12 thousandths of run out. So basically, I don't know what that means about my lathe chucks exactly, but that chuck clearly has too much run out. So that leaves me with the alternative of switching to a 4-jaw. The problem is, it's hard to describe without it being back on there, but you see how this has got lobes in it? Well, it worked out so that the inside of the jaws, as they're stepped, that when I grab it with a 3-jaw in here, the jaw has enough clearance to sit in here, but 6 lobes does not work out right with a 4-jaw chuck. And it's going to be really awkward. If I can grab it at all, I'm going to be way out on the tips of the jaws, so I don't like that. So we're going to try something different. I've already removed my 3-jaw, cleaned up the nose of my chuck here, and now I'm in the process of cleaning this up. This is an old faceplate that I got. I have never even used this. It was something that a friend had that I got from him, and I've never had a need for it. So now I'm cleaning this thing up. I'm going to put it on there, buff it up, check it for true, and if it's not true to this lathe, I'm going to skim cut the face of it. And what that'll let me do is know that all I have to worry about is, run out in this direction, not whether it's got wobble to it. So that's the direction we're headed. I will bring you guys back when I get her set up a little better. So we're making progress here. This thing has got these 12 holes around the back side, but they're in pairs, so they're on a 6-bolt pattern basically, or a 6-hole pattern. So what I want to do is I went to the hardware stores. I didn't have either a 14mm coarse threads, what those are, and I want to bolt it to the back side because this has slots in it that are laid out on all kinds of different combinations. Both 4s and 6s as far as I can tell. There's 4s. Let me see here. Am I thinking right? Oh, maybe not. But anyway, I'm hoping I can find the combination of holes that'll work in this. But the problem I've got right now is that these slots are cast into here, and they are obviously English. These things will almost go through. Some places they will, some they won't. I'm just going to clean up some of those slots a little bit with my die grinder, so that I can get the bolts in them, and then we're going to see if we can find a combination that lets me bolt this thing up here. They are so close to going to begin with that I really don't need to take much out of them. Basically just smoothing up the rough surface on the casting. Like that one's good to go already. So there's that one. Now I'm going to grab next hole over here. I'm going to get 3 bolts in this as the goal. Someone has already opened up specific spots on this at some point in the past for a project they were doing. Oh, we're getting close. So just to kind of give you what I will and won't do, like this probably looks a little hillbilly. If these were machine slots, I wouldn't be caught dead doing this. But the fact that they're rough cast slots, then it doesn't matter as much. Most of what I'm fighting is actually the draft here from the pattern. These slots have a taper top to bottom, and I'm really squaring them up a bit. Like I say, if they were machined, I wouldn't think of doing this. But cast, I don't mind cleaning up a casting to get over a hurdle like this. Especially when we were talking, I mean, such minimal material removal that it's almost negligible. Oh yeah. Good to go. By the way, these Metabo electric die grinders are probably one of the most amazing tools ever invented. I can't begin to describe how often I reach for that tool. It's one of those where you're like, is it possible, even remotely possible, that that thing's worth 300 bucks? And I'm going to say, I just said no. I got this one like new condition but used for about $80 and was kind of questioning whether it was worth it. I had an old, pretty tired Milwaukee, and I got to say, I don't know if it was because it was old and tired or if it was just that bad to start with, but the Milwaukee vibrated so bad it'd put your hands to sleep in about 2 minutes of using it. The Metabo, by comparison, is one of the most silky smooth tools I have ever used. So it just reaffirmed my deep love for Metabo tools. Now they're starting to build them in China too, so we'll see. I'm going to say I'm less than impressed, and we'll hope that that doesn't prove to be as bad as it seems like it will be. Alright, we got a whole new problem now, it looks like. Well, no, maybe we'll make it. It's looking like I'm having trouble getting on center, though. You gotta see here. Yeah, we are like not good. The hole pattern in there is about at the bottom edge of the slot, so now I'm concerned I might not make it. If I had socket head cap screws, it probably would be okay, but the trouble is I don't. I have normal, ordinary old hex heads, and we'll see, guys. This is looking a little iffy. I may have to change plans. It seemed like such a nice idea, too. That old adage, best laid plans of mice and men. Yeah, she's acting like this is going to be a no. Man, that's a bummer. I really wanted that to work, too. Alright, well, so much for that plan. Okay, plan B, everybody. We're going to have to go out to using this outer ring of holes. The reason I don't like that is because, first off, that pattern doesn't go all the way around, and that particular bolt pattern has got, I'll show you when I get this off, it's outside of a step, so as I'm tightening that up, it's trying to do an annoying combination. See, there's a step right here, trying to warp the part and kick it over, and the best that I can do is like those two, maybe. And that's assuming those line up with any of my hole pattern here. Would have been ever so much nicer if I could have just grabbed it off from that nice symmetrical bolt pattern, but oh well, life doesn't always work that well. Okay, so I gotta find some new bolts here. I'll be back. So, time to do some highfalutin measuring. Sorry, my camera got shut down and I forgot to start it back up. So, we got some voids in here, but I don't really care that much about a void here and there. They don't impact the fit that much. Got my Starrett ID mic set here, and we're gonna... Alright, I pulled it out of the lathe so you can see better. So I've got pretty good contact. I got a few little spots like there on the edge where there's a bit of a void. That one's not as bad as the camera makes it look, but for the most part, we're in pretty good shape. So I've ended up with, it was hard to measure in the lathe. I pulled it out because I was pretty confident we were where we wanted to be. So I'm showing, when I ID mic this thing, about 3 thou worth of press, 3.5. I don't really know how much press they wanted on here, but I know that we're really close to original because you see these bearings have a big radius on the back side. And I don't know if you can see it in the camera or not, but when I got down, so because of that radius, the bore was worn from this thing rattling around, but it doesn't reach all the way to the original bore. So see down here, I just cleaned up my brass. That's me touching the iron. Touching it on one side, not quite on the other, right? And like I went to great lengths to true this up. So I'm telling you, we are like within 1/2 thou. If anything, I suspect that I might be slightly smaller than what the original bore was. So I was shooting for 4 thou of press, basically 1 thou an inch. That's kind of a nice easy number, but seeing what we've got here, I'm happy with it. I'm going to load this thing up with some sleeve retainer when I put it in here just to give it a little extra oompah. That'll mostly fill in these voids and grab it and help keep the thing from trying to spin. But basically, I think we've got a good result, and she'll go a good long ways now. So I'll show you this thing once I get her pressed in, or maybe I'll set the camera up and press it in with the camera running. Got this Loctite 603 retaining compound. We're just going to run me a nice bead of that all the way around here, and then I'm going to take a finger and spread it around, gets all the nooks and crannies. Going to run a little bit of 603 around the outside of this. So I'm feeling much better about the fit on this bearing now. I was afraid that I should have, you always have doubts about stuff, right? Maybe you all don't, but I do. You're like, oh, I should have done this different or that different. And in this instance, what I was questioning after the fact was, yeah, that's 1 thou feeler gauge. And it does not go in anywhere behind this thing. So she's home. The only reason I was questioning that is because the top lip of this race, you can't see it, it stands up above the edge a little bit. And I kept thinking, man, I didn't think they would set it up from the factory to stand above the edge like that. But apparently I was wrong, and they do feel like that's an acceptable thing to do in this application. Alright, well, there you have it. One bearing mashed home. I just got to clean up the extra sleeve retainer, and she's good to go.